Algebra I, Quadratic Function. Quadratic Function Basic. Okay, so far we learned all the linear functions and linear equations, simultaneous equation, and we talk about what the nonlinear function is. Okay, the first basic nonlinear function you learn in Algebra I is a quadratic function. Quadratic function is, if you look at here, x and y are related by x squared. Okay, so if you draw this on the xy, not like a linear, it's become a curve. And what kind of a curve? Well, remember we did linear equation y equals mx plus b, and we figured out the relationship between the parameter in the equation. This is a parameter, it's an intercept, and m is the slope. Okay, so we do the same thing here for quadratic function, but it's not a straight line. So how do we do that? Okay, say we changed a is a parameter, right? Okay, what is the definition of parameter? Can you tell me? Okay, parameter is also variable, but we assume the parameter's value is given. You don't have to worry about it. Only things you have to worry about is independent variable, in this case x, independent, and y, dependent variable. Okay, and a is also variable, but the value is given for the purpose of drawing function on the graph. Okay, so that is called parameters. And you change a 1 and a equal b, a equal 3 or 0.1, you change your parameter, see how the graph look like. And if a is 3, the graph look like this. Okay, if a is 0.1, graph become very shallow plate, you know. A is 3 look like a cup, 0.1 look like a plate. So we can tell larger a makes a function steep, right? Less than 1 makes a function flatter. So just like this case, the b is related to the y-intercept and m is related to this slope of the line. We can relate the parameter with a graphic characteristic. Okay, graphic characteristic, you know, a is large number, then steep curve. A is very small, then it's become flatter. Okay, and this particular function, we can tell it's an even function. How can we tell? Do you remember even function definition? Right. So let's put negative x with the replacement of x, right? What kind of function is this? Same as x squared, because negative x doesn't matter. So this is even function, and for y is positive for all x, y is always positive. It never go to the negative side, and it sit on the origin of the xy coordinate. Right. Okay, so this is a characteristic of this equation. So what's happened when we start shifting the function? Do you remember shifting the function? That shifting characteristic apply to any function. Linear, nonlinear, doesn't matter. Okay, so if we shift x from here to here, the function is shifted, okay, by amount 3. Then what you do is -3, right? If you shift to the positive side, remember? You can go back to the shifting function and review this. So this kind of nonlinear function will be like this, right? Okay. Now, if we shift to the y direction, then it's going to be adding a c for the amount of shifting to the y direction, right? So it's going to be like this. So this is it tells you where the curve is on the graph x and y, right? Okay, but let's expand this. X minus b square is x minus b times x minus b. We expand this, okay, then it's become like that, okay? So we change the parameter into capital ABC. So quadratic equation, the general form will be a x squared plus b x plus c. Okay, so you expand this, then you get this kind of mess. So we redefine the parameter using capital A, B, C. Then this is a form of quadratic equation. Okay? So now we know anywhere, if you have x, y, if you have anywhere quadratic equation, just check at the bottom this coordinate. So we know this is shifting and this one shifting, so it's x minus a, right, square, and this curve is a. In this case we can say capital A and plus b, shifting b. That's a quadratic equation. So by looking at the graph, if we know the location of the bottom point, we can reconstruct the equation. From equation, we can also find out where this bottom line is. That's the subject we're going to talk about next. Quadratic function. Now we know we change those initial parameters. This a, small a and b, and the c. C is a shifting y direction, b is a shifting x direction, and a is a curve. How deep or how shallow the curve is, we switch to this. Okay, so a is capital A, this is v, and c. Okay, we solve this. So what's happened? C is equals minus b over 2a, and the c is 4ac minus b square minus 4a. Okay, so what's happened is we go opposite. If we know this coordinate, then we know how to construct this quadratic equation. The curve, which we don't know, but x minus this amount, right, and square plus c is this amount. We go reverse direction. If general form of the quadratic equation is given, Then we calculate B and C, so we know where the curve is sitting on the graph, X, Y graph. You know what I mean? So from graph to this is easy because it goes here and expanded. Okay, step 1, step 2. And equation to graph is step 1. Equation to graph is calculate B and C. This is step 1. Then make a curve. Okay. Here only things we don't know is this: the depth of the curve. It's narrow or shallow. That's we don't know. Okay. Okay, now we know graph and equation is a direction we can go. So let's establish as a formula, right? So if you go through, when somebody give you, here I have a quadratic equation. Okay, where is the bottom, or could be top, depend on A. If A is negative, let's see, this A is positive. If A is negative, the curve look down like this. So A is positive, there is a bottom point. A is negative, then curve, remember? Okay. A is 3, right? And become very flat for A equals 0.01. Okay. Very flat, A equals negative 0.01, and A become negative 3. So quadratic equations, the curve on the graph depend on A. Okay, so this coordinate can be calculated by this formula. If we know this coefficient A, B, C, just plug in, then you know where. So in order to draw the graph, the first things you to establish is bottom or top point depend on A. Okay, depend on A. A is positive or A is negative, because here A is same A, and once you establish the location, then you draw the curve, you get it. Another thing you can tell is intercept. Where's the intercept? Intercept is x is 0, right? You plug in x is 0, it's a C, so it's a capital C here. Here's a capital C. Okay, so having 2 point, the either minimum or max and intercept, now we know how to draw the curve by guessing. Okay, now what is the intercept for x? That intercept is called root, and we talk about this later. We need to study the roots a lot in the Algebra 1. The reason come out later. Okay, now minimax point and distance to root. Okay, when y equals 0, you set the 0, then this is equation, right? 0. So you move the c on this side and divide by a, so c divided by a, and square root is going to be x minus b. And you plug in b and c, because b and c can be calculated from a, b, c. Then you get this. Here you go. You have 2 root point. X is 0. Okay? So this is the root. You calculate center, B is the center, and this is going to be the distance. So this is a B, the amount you shift, and this is going to be distance from center to the roots. So this is a distance. This is important, okay? This part is a distance, and this is a center coordinate, the amount shifted to the x direction, okay? An example here, if somebody give you this quadratic equation, you use this formula, you can find root, 2 root as a square root, okay? And it's roughly 3.35 and minus 1.35, and center is B. So the graph is going to be 1 here, and here minus 1.3, 3.35, and the curve is going to be like that. And top coordinate is what? B and the C, right? Small one. And that can be calculated using the formula before. Okay, so now we know everything about the quadratic function. We have minimum point, max point, and the roots, and the y-intercept. The y-intercept is easy. It's a C, right? Now, what if the curve is like that? There's no roots. Okay, but if you calculate using the formula, you will encounter negative number inside the square root. That is, here you go, there are 3 examples here. You calculate by yourself, you'll see imaginary number. Well, it's not crossing x, so there's no roots. But you can still calculate the roots, except that the roots is going to be imaginary number mixed, is called complex number. And complex number cannot be plotted in this xy because x is a real number here, y is a real number. There's no way you can plot. How do you relate this kind of case to this? You cannot relate it because this graph is meant to be the relationship between the real number xy and the equation. But equation contain more stuff, which is a complex number, and it tells you that yes, the roots exist in the complex number domain, which is not showing this x, y real number graph. So we had to develop the new kind of graph to include this one, and we haven't done that yet, and you will not learn in Algebra 1. Okay, so in order to calculate the roots, what we need to do is to factor equation. In order to find out the roots, we have to do factoring. Factor the equation. What factor means is factoring the same thing as, say, 33 is factored into 3 times 11, right? So we do that at the equation level. The x squared plus 2ax plus a squared can be factored into this or expanded into this. Same way, x minus a squared can be expanded into or factored into this. The last example is this can be expanded or factored into this. Why factoring is important? Okay, this is a way to find out the roots. Easier way. You can find out the roots using that quadratic basic formula, or if you can factor it, it's pretty quick, because this is a no, this is B. The A is 1 here in this case, and C, right? And when you say 0, y is 0 is x-intercept. If you factor 0, either this is 0 or this is 0. So root is x equals minus a or minus b. Okay, so roots can be found out very quickly by factoring it, if you can factor it. Often you cannot factor it. This is expansion. This is factoring it, because 25 is 5 square, 10 is 2 a, so obviously this is factoring. And if 0, x can be minus 5 is 0. Oh, this case single root. Okay, the double root. Okay, so what does it mean? That means x, y, the minimum point is sitting on here minus 5, like this. If quadratic equation is like that, you have two different roots. If sitting on it, you have only single root, right? So same thing here, 7749 and 2714. Okay, now this one, factor it, then x-intercept will be minus 4 and minus 5. This one, you factor it, x will be negative 7 and positive 2. Okay, so now you have plenty of factoring practice to do, and that's what they do in high school in the beginning of the Algebra 2. So that's gonna be your life. Practice a lot of factoring, because there will be a lot of tests and quiz for factoring. Okay, thank you for listening.